SView is our model validation tool. In this video, I'll show you how to access SView after running a dynamic or nonlinear type of analysis to see the different results. This will give you a better understanding of your structure's behavior under certain loading demands. And of course, you can also share it with clients or colleagues. Please note that native SView files can be viewed by colleagues and partners without the need for an S-frame analysis installation. They just require completing a form at our website to gain access to SView. Here's the model we're going to use, a steel gantry structure. You can see I have some beam type elements and tension only members. Some sections, the material will be steel, and some pin supports at the base of each tower. If we move to the loading, the loads are defined in different directions, north and west. And we're going to focus on some load combinations I've created, load combination number 2 and 3, which also contemplates the north and west wind loads. Please note the model's loading was set in order to cause buckling instabilities. We go to run and run a nonlinear static analysis. And please note I set up 30 load increments to see how the model is changing at each step. I run this analysis, and when I go to the graphical results window, I can just click on one node of interest, access the incremental results, select the load combination that I would like to see, in this case load combination number 2. So we can watch the deflected shape, which is changing as more increments are added, until it gets to the point of instability. This helps us study the model's response to large loading and how its stability might be compromised. Of course, the model is non-linear, as you can see, and this is just looking at the x direction. If we look at y as well, we can see some linear behavior and then non-linear. Similarly with the z direction. Now if I open SView by going to run SView, I have the model open here. Here's the same model. I'm just displaying the object view, and I would like to see the load combination number 2 results, which is a wind in the north face. And then I click the play button, and you can see this is in the y direction. And if you will remember from the incremental results, the failure happens more or less at step 24. So, but it's happening from a bit early, and here's where the failure happens. And you can guess from just looking at the deflection results. Of course, this is an exaggerated view. You can modify it in the factor under the animation setup. Now let's jump into another model. This is basically the same model, but in this case, if we go to the loads window, I see I've defined a ground motion load in the x direction. And if I right click here, I can see I've assigned the Norwich earthquake. You have all the data here, and you have multiple support excitation ground motions that you can select from. I just happen to pick this one. I would like to catch all this part of the ground motion during the analysis, mostly up to 25 seconds, more or less. So if I go to run, I just set up the parameters for a linear dynamic time history, and my final step is of 25 seconds. I just run this model. Similarly, once you are in the graphical results window and check on your forces, you can go to run, SView. I have the model open here as well, just to save us some time. And I will select the ground motion load. And the good thing about this is that you guys can see how the ground motion is showing here in the graph. I click the play button, and you can see as it goes through each second, it goes through the different acceleration that is displaying here. So you see how the structure is behaving to this ground motion. You can also alter the factor or change it, let's say 250, just to make it more obvious to the eye. And you can decrease the velocity of this as well, and you can use the mouse just to see how it's behaving at each step. Thank you for watching.